we find the interior angle sum of a polygon, we're looking for the sum of all the angle at the inside vertices of a figure. We're going to start by using regular polygons because we know all their interior angles are congruent. Here we have an equilateral triangle. We're going to start by cutting off all of its vertices and arranging them to see if that'll help us find its interior angle sum. When we do that, we see we can put them together to form a straight line. We know a straight line is worth 180 degrees. So that tells us the interior angle sum on our equilateral triangle is also 180 degrees. Well, let's try that again with the regular quadrilateral. A regular quadrilateral is a square, so we're going to go around and cut off its vertices as well and see if we can arrange them to help us find our interior angle sum. When we do that, we see we can put its vertices together to make a circle. A circle is worth 360 degrees, so that tells us the interior angle sum on our square is also 360 degrees. Now, we're not going to be able to take all our figures, cut off the angles, and arrange them to find their interior angle sum. So let's look at another way we can work with regular polygons to find their interior angle sum. Here we have a regular hexagon and a regular octagon. On our regular hexagon, one angle is worth 120 degrees. So that tells us all its angles are worth 120 degrees. So I can take my 120 degree angle and multiply it by 6, and that gives us 720 degrees. So we know the interior angle sum on our regular hexagon is going to be 720 degrees. We can do the same thing with the regular octagon. One angle is worth 135 degrees, so that means all 8 angles are each worth 135 degrees. 135 times 8 gives me 1080, so we know the interior angle sum of a regular octagon is going to be 1080 degrees. Let's take the data for the shapes that we found and compile it into a table. We'll use that table to help us look for a pattern. If we look, triangles to quadrilaterals, 180 to 360, that increases by 180 degrees. Let's assume that continues on. So from quadrilaterals to pentagons, let's assume that also increases by 180 degrees. That means pentagons would have an interior angle sum of 540 degrees. And if we check for hexagons, adding another 180 degrees takes us to the 720 that we found. So continue that on for heptagons, add another 180. So heptagons would have an interior angle sum of 900 degrees. And continuing on that, adding another 180, that brings us to the 1080 we found for octagons. Well, we're not going to be able to continue that forever. So how could we use this data to help us find an equation for an n-gon, meaning finding an equation for a pentagon that has any number of sides, or an n number of sides? Well, since we keep increasing by 180, we know we're using multiples of 180. So triangles would be 1 times 180, quadrilaterals 2 times 180, pentagons 3, hexagons would be 4 times 180, heptagons would be 5 times 180, and then octagons would be 6 times 180. So to find the formula for any sided polygon, we know it's going to be something times 180. But we look, triangles have 3 edges, and we're multiplying by 1. Quadrilaterals have 4 edges, we're multiplying by 2. Pentagons have 5, and we're multiplying by 3. So that means every time we took our number of edges and we subtracted 2 before we multiplied by 180. So that means to find the interior angle sum for any polygon, we would need to take our number of edges and subtract 2, then multiply that value times 180. So rather than cut apart shapes or draw them out and measure angles, we can use an equation to find the interior angle sum. The number of sides minus 2 multiplied by 180. Here we're going to find the interior angle sum of this figure. If we count its edges, we can see that it has 10 edges, therefore we're working with a regular decagon. To find the interior angle sum for any polygon, we saw that we could do n minus 2, with n being the number of edges, and multiply it by 180. Well, since this figure is a regular decagon, that means there's 10 edges. So that means we're going to be doing 10 minus 2 multiplied by 180. Well, 10 minus 2 gives me 8, so we're going to be multiplying 8 times 180. 8 times 180 comes out to give me 1,440 degrees. So this tells me the interior angle sum of a regular decagon is going to be 1,440 degrees. Check out the other videos in our playlist and don't forget to click on subscribe. Thanks for watching!